Good day, grade 7 learners. I am teacher Peachy and welcome to another awesome episode of Ciencia. Because science is not just amazing, it must be fun.
Our episode for today is about saturated, unsaturated, and supersaturated solutions. To begin with, let's have a recall on the previous topic about the properties of solutions.
Let's dissolve the sugar into the water. What part of the solution is the sugar? How about the water? Great, you're correct. Now, we have made a solution.
Now, we are going to investigate the properties of the different types of saturations in solutions. Are you ready?
Solubility is the maximum amount of solute in a fixed amount of solvent at a given temperature. There are three types of saturations in solutions: the unsaturated solution, the saturated solution, and the supersaturated solution. Let's do some activity about the different types of saturations in solutions. We will be preparing the three types of saturations in solutions: the unsaturated, saturated, and supersaturated solutions. The materials that we are going to use are white sugar, water, a beaker, stirrer, alcohol lamp, wire gauze, tripod, and matches. The first procedure is we're going to pour 150 milliliters of water into the beaker. Then, we're going to put 1 teaspoon of sugar into the water and dissolve it. Do you still see undissolved sugar particles? What do you think is the type of solution that we have made? Correct. We have prepared an unsaturated solution.
Unsaturated solution is a solution that contains less amount of solute in a given amount of solvent.
The next step is we're going to put 2 teaspoons of sugar into the 150 ml water. We are going to dissolve the sugar into the water. We're going to add more teaspoons of sugar until all sugar particles can no longer be dissolved. Do you still see undissolved sugar particles? What do you think is the type of solution that we have prepared? Correct. We have prepared a saturated solution.
A saturated solution is a solution that contains the maximum amount of solute dissolved in a given amount of solvent. The presence of excess solute is an evidence that the solution has reached its saturation point. Saturation point is the stage where no more solutes can be dissolved.
I have here another beaker of saturated sugar solution to show you how a supersaturated solution is being prepared. The next step is we're going to heat the saturated solution until all the solutes have been dissolved. Do you still see undissolved sugar particles? We have now prepared a supersaturated solution. The heat did dissolve the excess solute from the saturated solution.
Supersaturated solution is a solution that contains more than the maximum amount of solute that is being dissolved at a given temperature. A supersaturated solution is unstable. When the solution is cooled, crystallization of the excess dissolved solute happens with the addition of a tiny crystal of solute called seed crystal. We'll now proceed to the abstraction of the lesson. This illustration is an example of a saturated solution. There is a constant amount of water present in all the beakers. In figure 1.1, it shows the start of the saturation process in which the solid solute begins to dissolve, represented by the red arrows. So the red arrows represent the rate of dissolution. In figure 1.2, much of the solid solute has dissolved but not completely, because the process of crystallization, represented by the blue arrows, has begun. So the blue arrows represent the rate of crystallization. In figure 1.3, a small amount of solute remains undissolved because rate of crystallization is faster than the rate of dissolution, as represented by the longer red arrow and a shorter blue arrow in figure 1.2, causing the amount of dissolved to be less than the amount of solute crystallized. Next shown is an unsaturated solution. Again, there is a constant amount of water in all of the beakers. Figure 2.1 shows the start of the process in which the solid solute is beginning to dissolve, represented by the red arrows. Again, the red arrows represent the rate of dissolution. In figure 2.2, a large amount of solute has been dissolved. The magnitude of the red arrows are much longer than the magnitude of those blue arrows. The blue arrows again represent the rate of crystallization. It means that the rate of dissolution is much greater than the rate of crystallization. In figure 2.3, the solute has been completely dissolved in the solvent. The last illustration is an example of a supersaturated solution. There is still a constant amount of water present in all of the beakers. In figure 3.1, we could see that there is a greater amount of solute compared to the saturated solution. There is still the red arrows present, which signify the rate of the solution. In figure 3.2, we could see that the blue arrow, which represents the rate of crystallization, is greater in magnitude compared to the red arrows. This means that the solutes begin to crystallize as it slowly decreases the rate of the solution. In figure 3.3, we can see that the blue arrows have much greater magnitude compared to the red arrows. This means that the large amount of solutes become crystallized and not dissolved. Here are some examples of unsaturated, saturated, and supersaturated solutions. Iced tea is an example of an unsaturated solution, as well as vinegar. More chocolate powder added can create saturation at the point that no more powder can be added. Carbonated water is saturated with carbon, hence it gives off carbon through bubbles. Hard candies like lollipops are examples of supersaturated solutions, so limit your intake of these. So now we have investigated the different types of saturation in solutions. Let's summarize again. Did you enjoy the lecture and the activity that we had? How about a little check-up quiz? Great! Please get a sheet of paper and ball pen to write your answers. Number 1. What is the maximum amount of solute that can be dissolved in a fixed amount of solvent at a given temperature? A. Concentration. B. Dilution. C. Solubility. D. Solution. Number 2. What type of solution that can still dissolve more solute? A. Concentration. B. Saturated. C. Supersaturated. D. Unsaturated. Number 3. How would you know if the solution is already saturated? A. If the solvent can still dissolve the solute at 30 degrees Celsius. B. If the solvent can still dissolve the solute at 60 degrees Celsius. C. If there are undissolved solutes at the bottom of the container. D. If all the solutes have been dissolved by the solvent. Number 4. Which of the following is an example of a supersaturated solution? A. 70% isopropyl alcohol. B. Baby cologne. C. Caramelized sugar. D. Vinegar. Number 5. Which of these actions will cause more sugar to dissolve in a saturated sugar solution? A. Stirring vigorously. B. Adding more solutes. C. Cooling the solution. Or D. Heating the solution. Here are the answers to the check-up quiz. So did you get 5 over 5 on our check-up quiz? Wow, that's great!
And that wraps up our episode for today. Again, this is Teacher Peachy, and always remember that science is not just amazing, it must be fun. Ciencia!